Okay, so the next topic is going to be quite interesting. So we want to know, at least based on your experience, right? A lot of people right now might be developing a lot of LLM-based models or agentic models, right? So imagine that people are working on building this LLM stack and they want to take it to production, right? That's where the real challenge is, right? When you kind of take it to production, you have to attribute multiple different things when you are going to have like multiple users consuming this as a service as such. Based on your experience, Gautam, what are things that you would say that maybe you can keep this as a checklist to see that you are covering this when you are taking your inference platform from your dev to production? What are the things that you would recommend to check out, especially when you want to hit production?
Sure. So, see, I've done two types of deployments, right? One
Mhm.
is, let's say that your pipeline is more conversational, right? So, wherein the user would look at a response immediately, right? There is a
Uh,
deployment called streaming deployment.
yes.
And then let's say that it's not very conversational. Let's say that the user uploads something and the LLM does its work in the background and he or she can wait, right? Then it's called
Yes.
batching.
Yes.
So first thing we have to figure out what is going to be the deployment mode, because each of
Mhm.
this comes with its own cost benefit analysis. So
Yes.
when we talk about the streaming, right? Again, right? The response have to be very quick. The latency
Mhm.
is going to be very, I mean, the latency we cannot afford latency basically. So that's going to be a much more costly affair. Whereas if it's batching, right, the user has to wait, but it is not going to be that as costly as streaming, right? And
Yes. Yes.
you have to figure out what is going to be the metrics that you're optimizing your deployment for. For example, let's say that you have different metrics like time taken for first token, right? That is one metric, right? Time between
Mm, mm.
tokens is another metric.
Yes.
So all of these are like streaming metrics, right? So for example,
Yes.
on an average, if you are generating 200 tokens per user per session, I'm just making it up. So your metric would be something
Mhm.
like this, right? Time to take taken for first token into time taken between tokens into number of tokens. That is going to be your metrics. And this is going to
Yes.
be something, I'm just giving you one example. It's not this simple, but it's for your understanding. For batching, right, you have other metrics like P95, P99,
Mm.
wherein you need to have that availability, where your agent or your LLM is doing some task. How quickly can this do a turnaround and with what availability? So,
Mm.
for example, if 100 users are waiting for some sort of a response, so out of 100 users, how many people got the quick turnaround time between, for example, if our benchmark is, let's say, 100 milliseconds, I'm just making it up, right?
Mm.
100 milliseconds is like one tenth of a second, right? So on an average, if you take 100 users, how many of them are getting their response within this SLA is going to be another metric. And this is
Yes.
for batch. And if that's being the case, how much of those response have integrity to it, right? That is
Mm.
another metric. Integrity is, I have an expectation. Is it meeting that expectation in terms of response? This is for batch. So
Mm.
these are the two types of deployment. And then,
Mm.
right, I was talking about, I briefly, I think, touched upon the KV cache, right?
Mm.
So
Mm.
when you send a request, it would go to this prefill, like I said. And then this is predominantly where most of the time is spent, because it has to compute this
Mm.
whole matrix operation when you send a sentence.
Yes.
And this is the reason why you wait for the first token. You can observe this in Cloud or Chat GPT. When you send a request, right, you'll have to keep waiting for the first token to
Yeah.
happen, and then subsequent tokens will occur automatically. This is exactly because of that KV cache, right, which
Yeah.
is memory bound, right? First token before it
Yes.
appears, it is all compute bound. Later, it becomes
Mhm.
memory bound. You also have to account for that. So your infra has to support that KV cache, right? So there is a formula wherein you first look at your model, and each of these models would have its own attention mechanism if you're using auto recursive for that matter. And can this attention, right? Can this whole pipeline be parallelized? That is where you
Mm,
have this GPU. And if so, what is going to be my cost at a token level, right?
mm,
And secondly, once all this is done, I also have to accommodate, this is computation. I also have to accommodate the activations, the model metadata, the model weights, and then
mm,
finally the KV cache it is going to generate. All this would have a cost incurred at a memory level, which is also something
mm,
that you will have to measure. And finally, right, this is one final consideration. For your use case, most of the time, at least from my experience, generally when
mhm.
people come, they say that I would need, 3 billion model or, 16 billion model, all of that. But if you look at their data, they wouldn't have that much of data with them, right? In
Yeah,
production, at least from what I'm seeing, right, people are requesting for a large model, but they think that large model is going to be more accurate, which is not the case
yeah,
most number of the times.
yes,
It is about
yes,
your data pipeline. Your data training pipeline would have a larger say in terms of how your model is going to perform than the model itself.
yep.
If you are into AI engineering, I would suggest using this book, right? This, I
Mhm,
consider this to be a Bible
mm.
for AI
Yes,
engineering, right? This is AI engineering by Chip Huan.
chip humor.
Most of
Yeah,
what I've learned is from this book. So please do buy this if you haven't already.
yeah. I mean, great insight. I too agree. I guess recently I've been like reading into one of the research paper, which is NVIDIA's Nematron 3.5. So when they release this ASR model, this ASR model is just 600 million parameters. And I've done a video as well quite recently on the architecture
Okay.
of this. So they have improved their, inference time. The throughput is almost 4 times than their previous model, which was a Parakit model, which was 1 billion parameter model. But right
Okay.
now, even with 600 million parameter, they were able to achieve higher throughput just by changing the way they compute their the audio. Basically they transform this audio into the tokens as such. So they built this cache aware system. While doing this encoding process, basically they cache the representation so that every single time they don't have to go and compute the previous
Hmm.
information that they have. I believe, I also sincerely believe on this particular part that you need to identify, I mean, you need to set your data pipeline in a better way and do not run behind the fact that more number of parameters in the model is going to give you the better results. It's not the case, right? In most of the cases, I do agree. And this book, awesome recommendation. I too read that particular book, and it's a must read for AI engineers, I would say.
It is so detailed, right? One of the best books I've ever read in terms of AI. It is so well written that, let's say that you're not an AI engineer, but someone who's interested, genuinely interested in AI, you would still be able to grasp a lot of concepts.
Super. Thank you, Gautam. Thanks for your comments, and thanks for all your suggestions, especially for the students and people who are aspiring to getting into this industry. So, people who are really interested, please check out Gautam's recent work, his tutorials on quantum computing, his tutorials on LLM based inference. Do check it out, and make sure you hit the like button and encourage us to do more such kind of videos. To be honest, I guess it's an amazing talk because this is completely unscripted. We didn't plan any of these questions. It's completely from our heart, from based on our experience. So thanks, Gautam. Over to you. All the closing notes.
Like I said, right? First, thanks a lot for having me, and it is my honor. I've known Srinath for a while. He's an amazing guy too, right? So do follow his work. His work in terms of putting tutorials are quite eloquent, I would say. At least, right? I don't have those editing skills. He chops up his video quite engagingly well, right? And it's my honor, and this is what I'd love to do. And please do have me more.
Thank you. Thank you. Do follow A Paatshal for more updates, and all the resources which is related to Gautam's work is there in the description. So do follow us and hit the like button. See you soon in an awesome podcast with Gautam on another topic. And yeah, thank you everyone. Thank you. Thank you, Gautam.
Thank you. Bye.
Bye bye.